Here's problem 30. Problem 30 gives us this rectangular park, and it tells us that PN is 195 and MM is 360, and so figure out what MO's length happens to be. Well, as soon as I see this, two things come to mind. Hey, I got some nice right triangles where the Pythagorean theorem really could help me. The other thing I noticed is it said it's a rectangle. A rectangle is very special in the fact that these diagonals are exactly the same length. So I know MO is exactly the same as NL. The other nice thing is they're going to intersect one another. So basically what happens is this length is the same as that length, is the same as that length, is the same as that length. Now that might come into play and help us. But otherwise I'm thinking, hey, I'm looking to look for the right angles, since all of them are right angles, and I got a bunch of triangles here, so I'm thinking maybe Pythagorean theorem. But let's see what we have. It says PN, P to N is 195. So this length right here is 195. Before I go any further, if he's 195, I know this guy's 195, and I know that this is 195, and this is going to be 195. Now, MN, M to N is 360, so if the top's 360, down here is 360. Maybe I want to find that. What does it ask me? It asks me M to O. I don't even have to try and find this. Now, I could find NO. That could have been a different problem where I would have used Pythagorean theorem. If there's one side, hypotenuse right here of what, 390, and use those values. But I don't even have to. It's basically saying, hey, what is M to O? They were trying to trick you pretty much in the problem to see if you knew, hey, since that's 195, that's 195, and checking to know that, see if you knew that in a rectangle, diagonals are exactly the same length. So if I just add 195 and 195, that should be 390. So that's our measurement.